morning, good morning, good morning. The last day of reInvent. Who went to Dead Mouse last night? Raise your hands. Who thought it was pronounced Dead Mouse before last night? Yeah, some people in here are lying, I can tell already. My name is Craig Carl. I'm a solutions architect with Amazon Web Services. We're going to talk today about NFS and CIFS, Network File System and Common Internet File System. What are they? They're protocols used to implement shared access to files. They're on-the-wire protocols. They leverage TCP back in the day. NFS leveraged UDP. Now they're TCP protocols. They're different from block and from object store. So object store uses RESTful, puts and gets. NFS and CIFS use fopens, fclose, fwrites. Current versions, NFS v4 and SMB v3, but in my experience, we're not seeing a lot of NFS v4 or SMB v3 yet. So is anybody here running NFS version 3 in production today? And what about version 4? Okay, all right, so a good mix. And who's running CIFS? Who uses Windows? Not too many. All right, some. Yeah, all right, some. So, do you need an NFS or CIFS file system that's shared? We have S3. Wherever possible, we say to people, use S3. It's bigger, it's more robust, it's easier to make highly available. If your application can be modified to use S3, use it wherever possible. We like loosely coupled stateless infrastructures in the cloud. And it's hard to build a loosely coupled stateless infrastructure if you're using NFS and CIFS. But there are some places you need it. If you're running a bunch of Oracle, if you're running SAP, if you're running legacy applications, even some new stuff, WordPress really wants an NFS or CIFS file system in there somewhere. Shared or clustered file databases, right? MySQL, PostgreSQL, they all run really well using NFS as a backing store. Or you want multi-instance read and write access to the same data set, and you want to modify files in situ. So with S3, you need to get a file, modify it, put a file. If you want to just modify a file in place, that's a good place for NFS or CIFS. So we're going to talk today about how you can build your own NFS and CIFS infrastructures. And then we're going to talk about some of our partners who deliver that stuff either as a prepackaged software solution or as a service. We're going to move pretty quick. Today, we've got lots of architectures to look at. We've got some code samples to look at. Everyone in this room will get an email on Wednesday with a link to this video recording, a link to the presentation, a link to a GitHub repo with all of the code samples and all of the snippets, plus footnotes and links and references to all of the documentation. So you'll all get that on Wednesday of next week. So if we blow past something quickly, you can get it on Wednesday, plus I'll take Q&A at the end. So, if you're going to build your own NFS or CIFS store, what do you have to think about? One, availability, right? A single availability zone in an Amazon region could fail at any time. So if you put your solution in a single AZ, you have an availability challenge. So we're going to talk about if you build it in a single AZ, what's your recovery process? Or how do you build it so it spans availability zones? Talk about the durability of data. We're going to get into the backing store. We're going to talk about the performance characteristics. We worry about this on 3 dimensions primarily. First, the internet or public-facing interface, that where your clients are talking to your NFS server. The network that we're connected to EBS, if we're using EBS as a backing store, we need to worry about the performance of that network connection. And then we need to worry about the actual performance of the disk, the actual EBS volume. So we're going to get into a discussion of EBS and P-IOPS and EBS on HPC machines. And consistency. If you think you put foo.txt down on disk, will you get foo.txt back when you go to read it? And we'll talk about that as well. So let's start by talking about the stores that are going to back your mount. EBS is durable in its very nature. It has an annual failure rate of 0.1 to 0.5% per volume, which is roughly comparable to a RAID 5 array at your Drobo at home or in your office, right? Roughly equivalent to that array. Ephemeral storage are the disks that are available in the local instance. Okay? They're nice because we don't charge you for them. They're no additional charge on top of the instance charge. But they're not protected unless you protect them yourselves. You can't snapshot them off to S3 the way you can with EBS. So you have a real serious durability problem with ephemeral. But they're fast. They're wicked fast. Right? Our new i2 8 extra large instances have got about 5.7 terabytes of SSDs at 350,000 4K IOPS per second. I mean, they're just fast. And we're going to talk about how we can leverage that instance size and still build a high-performance, consistent, durable NFS store. And then S3. It's really, really attractive to say, I'm going to put an NFS and CIFS store on top of S3. But there needs to be some real intelligence in that layer. Because S3 doesn't have locking. It doesn't have partial file writes. It doesn't have it has partial file reads. It doesn't have partial file writes. So there are some open source projects that do it that have some real serious data loss potential. And we're going to talk about a partner solution, two partner solutions that have solved some of these issues that I think are viable solutions for delivering NFS and CIFS on top of S3. So let's look at the most basic. And what we're going to do is we're going to look at the most basic. We're going to work our way up to more complicated, building and building and building on top of things. So this is a single EBS-backed instance. So I have one instance running in one availability zone. I want to be able to grow it to a reasonable size, so I attach a bunch of EBS volumes to it. Okay? The nice things about EBS volumes is one EBS volume is capable of X IOPS per second. If I take 6 of them or 8 of them and stripe them together, it's capable of X times 8 performance. So not only by taking 8 EBS volumes and putting them against one machine, I get 8 times the performance of a single volume and 8 times the space of a single volume. The sweet spot is 8 EBS volumes on regular instances. Right? At 8, the network bandwidth, the EBS, becomes the bottleneck. So that's the sweet spot. I then need to take these 8 volumes, I need to put them together into a RAID array, and we're going to use MDadmin to do that. And we're actually going to look at the code that does this, plus a really neat open source project that makes it much, much easier. I then want to snapshot that array of volumes to S3. If I snapshot just one of those volumes, it doesn't do me any good. I need to issue an AWS EC2 create snapshot against all 8, and I need to do it at the same time. So there's an open source project called EC2 Consistent Snapshot, maintained by Ubuntu, and that's what's going to let us take a snapshot of the array. Okay? We're going to look deeper at the performance considerations of this and all of the other instances, or all of the other architectures. So, we talked about the public-facing internet connection on the machine can be a bottleneck. Low performance. I don't want to see anybody building this on a T1 micro. Right? That machine is 6 cents an hour for a reason. It doesn't have a whole lot of network oomph to it. It's fantastic. If you run a fleet of 600 of those to serve up your website, they are cost-effective. They're incredibly useful. This use case, no. No. So we're going to try and avoid the ones that say low performance. They give you a sub-gigabit of network connectivity out to your clients. So let's avoid those. Moderate performance. This gets you about a gigabit of performance from these instances out to all of your clients. So these are a good choice. Let's say you've got a whole bunch of T1 micro web servers that want to access a shared NFS store. You could take 30, 40, 50 T1 micros and point them in a single M1 extra large, because the M1 extra large has got plenty of network bandwidth. Okay? And then, of course, we've got our HPC instances that have 10 gigabits of network bandwidth. So I could take 10 M1 extra larges, point them at a CC14 extra large, and saturate all 10 of the network connections on my clients. Okay, so you're going to think about how many megabits per second do I want to do on the public interface when you're choosing a server. And the really nice thing is, if you say, you know, today I just need an M1 extra large, you create it. 6 months later, you say, you know, my bandwidth's a bottleneck. You do an EC2 modify instance attributes API call. You change your M1 extra large to a CC2 8 extra large. You reboot, and you've gone from 1 gigabit of bandwidth to 10 gigabits of bandwidth. The wonder of the cloud. All right, let's talk about the EBS-facing interface. This is very important. So there's an analogy of EBS to iSCSI in this when we're talking about network bandwidth. So you're building an iSCSI network on premise, and you have to say, am I going to buy 1 gigabit interfaces for EBS? Am I going to buy 10 gigabit interfaces for EBS? Or sorry, for my iSCSI. The same question comes up here. We call it EBS optimized and 10 gigabit instances. So without EBS optimized, it's best effort. We will do everything we can to get you really good EBS bandwidth, right? But there are no commitments and there's no guarantees. If you do EBS optimized, we offer EBS optimized on a bunch of different instance types. On M1 larges, M2 2 extra larges, and M3 extra larges, it's 500 megabits from your instance to the EBS fleet, which means the fastest you'll be able to read and write from those 8 disks that we've attached is 500 megabits. Probably not what you want. So you're going to step up to EBS optimized on an M1 extra large or some of those other instance types. That commits to you a gigabit with an SLA. Okay? You're going to decide how much performance you need. We can stripe together 8 4,000 P-IOPS volumes, and we can build one, 32,000 IOPS volume? No, not that many. My mouth sucks. Anyway, we can build one very fast volume, or we can take 8 standard volumes and build a volume that's fairly fast but a little bit variable. Okay? On our HPC instances, that 10 gig interface we talked about, it's not just public facing, it's also to EBS. So if you have 5 megabits or 5 gigabits of traffic going out to your clients, you have 5 gigabits free to go to EBS. So that can be very, very fast. Right? We announced a couple of weeks ago that on our 10 gigabit machines, there's enough bandwidth between an HPC instance and the EBS fleet to move 800 megabytes per second of traffic. So if you need a very high performance NFS mount, this is one way to do it. So let's look at the code. This is it, by the way. You spin up an Amazon Linux instance, and this is how you get it up and running as a NFS mount point. The first line, we install NFS and Samba. Samba is how we get CIFS working. The second line, we use a great piece of open source software. This thing's fantastic. Normally, to create a RAID array, we create our 8 volumes. We mount our 8 volumes to our machine. We do an mdadmin create, and we create a RAID array. Then we format and mount that array. Or you can go to GitHub, download RAID Former, the link to RAID Former is down at the bottom of the screen, and pass in a single command line. That creates your volumes, that mounts your volumes, that creates the mdadmin array, that formats it and mounts it all at once. So I put this script in my user data, so when the machine launches, it automatically attaches a bunch of volumes, formats them, and makes a RAID array out of them. I then edit my Etsy exports and my Etsy Samba files, and I start the 2 services. So it's very easy to get up and running. But again, you have an availability problem with a single instance and a single availability zone. Your recovery process is this. That availability zone fails. You go to another availability zone. You create volumes out of your snapshots, because you've been snapshotting all of these volumes on a regular basis. You spin up an instance in your new availability zone. You attach the volumes to the instance. You rebuild the RAID array. And then you install NFS and start the machine up, or start the service up. So it's not pretty, right? But it's easy and it's inexpensive, and if you don't have anything critical, it will work. So let's talk about another solution. All right, let's build upon that. Let's say that EBS isn't fast enough. EBS has higher latency, and there are certain circumstances when EBS won't service the workload. So what we can do is we can leverage the ephemeral drives as cache, right? And this is a good architecture. So what I can do here is I can take that new I2 with about 6 terabytes of incredibly fast disk. I create a RAID array of that incredibly fast disk, and then I use an open source project called DRBD to asynchronously replicate the blocks from the ephemeral to EBS. EBS is already much more durable than the ephemeral, and I can snapshot that EBS array to S3, so now I'm incredibly durable. Okay? This is a solid, good architecture. You still have the same recovery path, but you've just, for 0 additional cost over the other version, increased your performance 10 or 15-fold. Okay? But still a tough recovery path, and we're going to talk about that. I've done some testing. If I really, really aggressively write to the ephemeral disks, I cannot get EBS more than about 8 seconds behind. So that's when it comes to durability. If you lost the instance, if the instance failed, in my testing, you will lose about 8 seconds of data that hasn't made it from the instance to the ephemeral store. And that's been my experience. You can monitor that, and it's incredibly important to monitor that. The command to monitor is at the bottom of the screen. And that'll tell you how far out of sync your EBS volume is with your ephemeral volume. Okay, any questions on this? We covered a couple of real important topics we're going to dive into a little bit deeper. Any questions on this so far? All right. So let's look at that DRBD configuration. It's fairly straightforward. It's a very mature product. It's not difficult to do. Here we create the globalcommon.conf file for DRDB. We set the protocol to protocol A, which is asynchronous replication. Okay? And then we configure the actual resources. Here, I'm replicating on one machine to another machine. So my online are the same. I'm replicating from DRBD0 to DRBD1, MD0 to MD1 on the same machine, right? With asynchronous replication. Let's kick it up a notch. Let's solve the recovery problem, right? This is a good architecture. Okay? I have one machine in availability zone A. I have another machine in availability zone B. On both, I've attached a whole bunch of disks. I've created an MD admin array. So we've taken that original single instance with EBS, and we've duplicated it in another region. We're using DRBD now, the same DRBD config that we used before, only now we're replicating not from the same machine to the same machine, but from one machine to another machine. The config is exactly the same, except for I change the device name right here. That would become a machine in AZB. Right? So there's not a significant change. We use Linux Pacemaker, which is a standard open source clustering heartbeat technology. And the secret sauce here is, how do we get it to move IP addresses for us? We've got this exported on 10.0.0.1, and we want to continue to keep it exported on 10.0.0.1 when we move to the other availability zone. Linux Pacemaker normally uses a gratuitous ARP, a layer 2 ARP, to tell the switch it's attached to, hey, 10.0.0.1 has gone from this port to this port. If you send a gratuitous ARP on the Amazon network, we put it in the bit bucket, right? It goes to dev null, we ignore it. So that isn't going to work. So the secret here is getting Pacemaker to use our APIs to move that IP address. Bam, it's not that hard. Right? Pacemaker uses a script. So right now, if you installed Pacemaker, it would have a script that did a gratuitous ARP. We replaced that script with the one thing that uses our API that does an AWS assigned private IP address. And now Pacemaker can move IP addresses around members of a cluster. Right? All full configs, right? Everything you need for all of these is at the end of the deck, and you'll have access to it on Wednesday. Okay? So this is a solid config. This is almost what I do. So the next thing we're going to talk about is what I do. Okay? Let's say EBS isn't fast enough. We're building and we're building and we're building on top of things. You've obviously figured out by now you could just cluster ephemeral to ephemeral. Now you're durable. If an ephemeral drive on a machine fails, that's fine. You just move over to the other AZ. So you'd have to take multiple failures for this to break. And it's very, very fast. It's 350,000 IOPS per second fast if you do it on an I2. So incredibly fast NFS. But you still have a durability problem. The holy grail of durability at AWS is S3. So I really, really want to get this data to S3. So let's complicate things just a little bit more. This is what I run when I'm building NFS clusters. Okay? I take the ephemeral, I mirror it to the ephemeral synchronously. So when it's committed to the machine in AZA, the client does not get a commit until it's committed on AZB. So I'm incredibly durable, and I have consistency between my two instances, and then I use asynchronous replication to get it down to EBS. So this is incredibly fast, incredibly durable, and a little bit expensive. But it's a good, solid config. And if you're going to go build it yourself, and we're going to give you some alternatives. If you're looking at this and going, this is a lot of work, we're going to give you some alternatives. If you're going to go build it yourself, and it needs to be fast, and it needs to be mission critical, this is the architecture to use. And I've given you all of the pieces. You're going to use RAID former to build the RAID arrays. You're going to use DRBD synchronously between the two instances, and then asynchronously onto the EBS volumes. Okay? Solid configuration. You're limited here, though. I would never recommend you attach more than about 16 terabytes of EBS to most instance types. You're not going to want to go above that. At that point, you start saturating the network connection to EBS. There's an exception up at the high end of the instances, CC2s, CR1s, HI1s. You can get away with about 25 volumes. But you're not going to want to go bigger than that. So you say, Craig, what if I need a petabyte? What if I need 2 petabytes? What if I need 3 petabytes of storage? So the last company I worked at was Gluster, before they got acquired by Red Hat, where we built these sorts of architectures. And Gluster has some advantages, and Gluster has some disadvantages. Advantage, you can build great big clusters. I've built multiple 2 petabyte NFS mount points out of Gluster in AWS. So you can build big, big ones. Is anybody here familiar with Gluster? Does anybody use it today? Okay, so lots of people use it today. If you don't get Gluster, if you've never looked at it before, it's magic. You take the storage off of 1 or 5 or 10 or 50 instances, you make a single mount call, and all of a sudden, all of that storage appears as a single drive, a single NFS, CIFS, or Gluster FS mount point. It's magic. It really is incredible stuff. We have some challenges. With file sizes under about 128 KB, it gets very, very slow. With file sizes under 32 KB, 5 megabytes per second, 6 megabytes per second. With 2K, 4K files, 2 megabytes per second. Distributed file systems and small files do not work well together, right? It's a challenge, okay? To get true high availability, true redundancy from Gluster, you need to use their client. Their client is a 64-bit Linux client. So if you're using Linux, you can use their client. It works just like NFS. The operating system thinks it's NFS. It looks like NFS, only it adds some durability. And it does it in a couple of pretty cool ways. But if you want to attach Windows to this, it'll work. Every one of these 10 machines, you export Samba, and you do a loopback mount to Gluster. But that means if that machine that Windows client happens to be connected on fails, it has to reconnect to another machine. So you end up doing some fancy round-robin DNS stuff. And you do the same thing with NFS, right? So if you can use the Gluster client, and your file sizes are not very small, right, if they're larger than 128 KB, then Gluster is a great option. It's a great option. It's not for beginners, right? I'd say you need to be medium to advanced Linux administrator to set up and maintain Gluster. A lot of the tools that we've talked about already, you can use. You're going to attach 8 drives to every one of your Gluster instances. You can use RAID former to do that. And then you install Gluster everywhere. And actually setting up the server is really, really easy. On any one of those machines, you do a Gluster volume create. So first you do a Gluster peer. You make them all part of a cluster. And then you do a Gluster volume create. I'm doing replica 2. And what replica 2 means is it's going to take the first server line, 10.0.0.1, and it's going to replicate all of the data on that machine to 10.0.1.1. Then it's going to take everything on 10.0.0.2 and replicate it to 10.0.1.2. So you get to control where things are replicated. So you can say everything in AZ1 gets replicated to AZ2. Okay? Gluster is a great option. It's open source, maintained and run by Red Hat. On the client, you use the standard mount command, and when you install the client, it adds a protocol. So just like you would do mount-t NFS, you do mount-t Gluster FS, any one of the Gluster servers, and if that server died, it doesn't matter. What the client does is it goes to that server and it says, give me a list of every machine participating in this cluster, and then the client load balances connections across all of those machines. So you've got a really even distribution of reads and writes. Right? Because we're replicating, the client knows that the file it's trying to read from is on 2 machines. So every couple of seconds, it says, what machine am I getting faster responses from? Okay, I'm going to do all my reads from there for the next 5 or 6 seconds. And then it'll check again. So it's really intelligent. It's a really nice piece of software. We run into challenges with smaller files. Okay? And the work involved in maintaining Gluster. Okay? Red Hat also sells a paid supported version, Red Hat Storage. The Red Hat Storage people, is there anybody from Red Hat Storage in the room? Oh, a couple, we're going to try and make it. They have a booth in the main conference hall. I'll give you the booth number. If you would like Gluster that somebody else sets up and maintains for you, they will be happy to do that. Let's talk about Windows. We have some Windows people in the room. Before Windows Server 2012, I didn't have a really good answer for you here. Right? With Server 2012, I have a really good answer. DFS got very, very nice. So we can do a standard Windows instance, attach a bunch of EBS to it, and export CIFS. You have your durability issues, you have your availability issues. How do we make that more redundant? We use DFS. And DFS got really, really nice in 2012. And so that's good. We've got one downside. So I can take 2 machines running Windows. I attach 8 terabytes of disks to both of them because I need 8 terabytes of storage. I can click through a couple of windows. It's real quick, and I can set up a DFS cluster. And then the Samba client will write to both machines for me synchronously. And it'll read from both machines from me depending on the performance. So it's a really good solution. You can do it with ephemeral disk. You can do it with EBS. You've got a whole bunch of options. Problem is the clients have to be SMB-v3, which means your clients need to be Server 2012 as well. Okay, I don't have a good answer for you if your clients are Server 2008. That's a hard, high availability problem to solve, and I don't have a really good answer. But if you're Server 2012 everywhere, then DFS on Server 2012 is a fantastic option. Okay? So you're saying, wow, that's an awful lot of work. Doesn't Amazon make it easier for me to concentrate on my web development? Doesn't it make it easier for me to concentrate on my analytics and not build infrastructure? Yes, we do. And so we go to partners and we say to partners, make this easier for our customers. And they do. So like I said, Red Hat Storage is here on site, booth 400. If you are sitting here needing, I need a petabyte of NFS, go talk to these people. They will sell you support and professional services to set that up and to help you maintain it. Okay? Maginatics is also here, booth 1006. So these are a lot of the folks that came from AFS. They built a compelling solution. It's highly available across availability zones. It uses S3 on the back end, so you've got tremendous durability. And it's got deduplication and some strong encryption built into it. So it's a compelling solution as well. They're here in the building. Is there anybody here from Maginatics in the room? There are, so we've got a couple of people from Maginatics in the room. Track them down at the end of the session, and they can help you. SoftNAS. SoftNAS is available in the AWS Marketplace. It implements, and I'm going to fly through some slides here real quick. Their software implements this for you, top to bottom. You can run 2 SoftNAS devices. It replicates between the two using ephemeral and/or EBS, and then it caches and stores the really durable stuff instead of EBS down to S3. So SoftNAS has a great solution. It's a GUI top to bottom. So for those of you that are like, you know, I just want something that looks like a NAS device that runs at my office. I've got 2 controllers and a bunch of disk, and it just works. SoftNAS is an option. Okay? Zadara, booth 711. I'm going to invite Noam-Shendar up on stage. Zadara is my favorite solution for this problem. Okay, and that's why we're inviting Noam on stage. Noam delivers virtual private storage arrays as a service. So he delivers to you NFS and CIFS, not as something you build yourself, not as something you maintain yourself, but as a service. Thank you, Noam.
Thanks, Craig. Clicker. All right. Thank you. Happy Friday, everybody. I'm very happy to be here. I'll try to match Craig's energy level, but it's an impossible task. I'm going to tell you a little bit about Zadara storage. I want to leave time for questions, especially for Craig. So let's get into it. What is Zadara? We built a private storage as a service offering for AWS customers that's billed hourly and doesn't require any configuration or DRBD or MD-admin or anything like that on your part. It mounts directly to your virtual machines and via the standard NFS or CIFS or iSCSI interfaces. I'll talk a little bit about the architecture, but a key point to know is very, very low latency because it's co-located with Amazon's clouds, but without running on AWS's own infrastructure. The footprint is global. It's in 4 different regions: US East, US West, the Tokyo region, also called Asia Pacific Northeast, and Europe in Dublin. The quality of service is ridiculously high. This is not an exaggeration. I'll talk a little bit about that. And it's built with no single point of failure, fully redundant, and thanks to the multi-region capability, it's also resilient against disasters. This is where it sits and a little bit about how it works. It sits in 4 co-location facilities that are the Direct Connect facilities that AWS has, and you can see them listed here, and we're adding more all the time because there's a lot of demand for this service. And we use Direct Connect in a lot of it. It's between 20 and 40 gigabits of dedicated bandwidth in every single site, and that is elastic as well. We can add additional bandwidth as needed for a total of 100 gigabits of dedicated bandwidth going in and out of AWS. In the storage, because it sits at Direct Connect, is visible to all AZs in that region at the same time. So I'll talk about sharing as well, but now you can share the storage to multiple VMs, not only within an AZ, but actually across all of the AZs in that region. And we offer secure remote replication among those regions. I'll touch on that point in a second. The the provisioning is super, super easy. This is the live production screen that you would use to provision this for yourself. You would obviously specify which region you want the storage in because we need to know where to create your instance where it's close to your compute. Once you specify the region, you make 2 selections. One is the size of your Zadara engine. Think of the Zadara engine as a virtual controller, and the bigger it is, the higher your peak performance is going to be, and that is fully elastic. You can grow your engine or shrink your engine on demand non-disruptively based on what your application needs. And then you select the drives, and these are actual drives. These are spindles. They can be SSDs, they can be rotating drives, they can be any mix of the above, and they're yours and yours alone. No other customer is touching those drives, no other customer is affecting the performance of those drives, and that is elastic as well. You can pick more drives later, you can give drives back, you can wipe those drives clean if you don't trust us to do that. That is all part of this. And from the moment you hit submit at the bottom of the screen, 90 seconds later, your fully redundant, high availability NFS, CIFS, or iSCSI storage is ready and running. So why our customers use this? There are many reasons, and I'll just touch on some highlights. Every single volume has an SSD read-write cache, which does a really, really nice job, especially on random workloads, and even nicer on random write workloads. I mentioned the volumes can be shared. I also mentioned that the volumes can be huge. There's actually no real limit on the size of the volume. So we have customers using 100 plus terabyte volumes. Snapshots are instant and immediately available. mentioned the protocols, and the remote replication gives you as little as 5 minutes of RPO, recovery point objective. We also offer data at rest encryption as well as data in-flight encryption. A nice twist on the data at rest encryption is that you control the encryption-decryption key. We do not, AWS does not. So you need to manage that key for yourself. Good news is that means nobody else can touch your data. Bad news is don't ever lose the key. If you lose the key, you're done, you're hosed. And we actually put up a warning screen before you enable encryption saying literally 5 different ways you'll lose the data irretrievably, it'll become inaccessible, it'll be lost, it'll be gone, it'll be dead. There's no recovery. And then all snapshots are instantly clonable, and the clone is an instant zero-capacity read-write volume that is an identical copy of the snapshot. You can do that as many times as you need. It's really nice for test and dev, for example. And no limit on the number of volumes. Just create as many as you need. And each volume could be iSCSI or NFS or CIFS, your choice. And you can mix them. One really nice use case is DR, or business continuity. So using the snapshots, you can have these automatically scheduled, say every 5 minutes. In case there's a database corruption, something like that, you can go back to a previously working version and immediately be up and running again, and then in a relaxed fashion figure out what went wrong and roll in transactions as necessary. Remote replication uses the very same snapshots to create the same state in one of the other regions, or even on-premise if you want to work with us that way. And recovery, as I said, as little as a 5-minute RPO in the event that something went wrong, let's say with the software or even with the facility. Customer example, a company called IG. It's the largest internet portal in Brazil. You can think of it as the Yahoo of Brazil. They're attaching 170 NFS clients to our virtual private storage array, to a single virtual private storage array, obviously moving a lot of data, terabytes and terabytes per day. And you can see just a short list of the volumes that they have here. It's actually a much longer screen. I think that takes me back to Craig, and who's going to summarize this for us. Thank you.
Thank you very much. Thank you very much, Noam. Thank you very much, Noam. So Noam's being a little bit modest. He didn't talk about their newest feature, right? They now can, has anybody here used NetApp on-premise? NetApp on-premise, okay. You can now snap mirror to Zadara, and you can snap mirror back from Zadara. You can use ONTAP on Zadara. So if you have on-premise workloads and you want to snap mirror them to AWS, talk to Noam. Noam can help you with that. We covered a lot today, and we're going to take some time for Q&A. We talked about single instances and how they're inexpensive, but you have an availability and a durability problem. We talked about ephemeral drives that are super fast, but you have an availability problem. We talked about clustering things together, which solves your availability and your durability problem, but there's a cost. So we talked mostly about trade-offs and options and the ideas behind some of these code and CloudFormation templates to build everything you see will be sent to you on Wednesday. So we can give you easier ways to build this. We have folks here at the conference from Zadara, Maginatics, SoftNAS, and Red Hat Storage. They can help you with this problem as well. So questions, please.